For this video, we are going to be discussing congruent figures. So congruent figures are just two shapes that all of their corresponding parts have equal measures. So two shapes are said to be congruent if all of their corresponding parts have equal measures. Meaning, like if I look at these two triangles, okay, I can see that side DF and side AC are congruent. Sides EF and BC are congruent, and sides AD, AB, and DE are congruent. These little hash marks tell you they're congruent. The same number of hash marks are congruent sides. So all three sides of these triangles are congruent, and also so are their three missing angles, or their three angles, 50, 50, 60, 60. And when we say corresponding, it means that they're in the same location on each triangle. Like we know that between the sides with one hash mark and two hash marks, that's where 50 degrees should be. Or conversely, the sides with one hash mark should be between 50 degrees and 60 degrees. And we can use this to find like missing information. Like if I know that this is 50 and this is 60, well, 50 plus 60 is 110, so that makes this 70 degrees. And since these two triangles are congruent, then this one also has to be 70 degrees. So shapes are congruent if all of their corresponding parts have equal measures. Now we can use the names to determine which parts of each shape are corresponding. For example, if I have triangle ABC and triangle XYZ, well, I know that, for example, side AB corresponds, I'm just draw this little arrow for corresponds, to side XY. And I could tell that just from the name. A and B are next to each other, so X and Y are together. Similarly, BC corresponds to YZ, and AC corresponds to XZ. All right, that's how we can use the names. So the names actually matter what letters we put, what order we put them in, because we can use them to determine what corresponds with what. You can do the same thing with angles. Angle ABC corresponds to angle XYZ. Okay, and I could keep going. Angle BCA corresponds with angle YZX, and angle what? CAB, or BAC, I could do BAC, corresponds with angle YXZ. Okay, and we can just use the names to come up with what corresponds with what. And all of these things are also congruent because we said the triangle is congruent. And we can use this information to find missing measurements. So in these two triangles right here, we know that triangle ABC is congruent to triangle PRQ. Now I've got all this missing information here, and it's pretty easy to fill out. If I want to find out, for example, what 2x plus 17 was here, well, I can use my information. I know that PR is congruent to AB, both from the name and from the fact that they both have a 9. I know that BC is congruent to QR, all right, also from the name and also from the fact that they both have an 8, which means, well, AC is congruent to QP, although that's not particularly helpful here. What really is helpful is the angles, okay? I know that angle RPQ is going to be congruent to angle BAC, right? They're both between corresponding sides, so if this guy is 60, then this guy is also 60. All right, and I know that angle PQR is congruent to angle ACB, which is right here, making this one 67 degrees. All right, and well, now I got to figure out what 2x plus 17 is. Well, to figure out what 2x plus 17 is, I can go over here and I can say, well, 60 plus 67, that's 127. All right, do 180 minus 127, I get what? 53 degrees. So this is 53 degrees right here. Okay, so if that's 53 degrees, well, and I know this is 2x plus 17 to find x, I can just say 2x plus 17 equals 53 degrees minus 17 on both sides. I end up with 2x equals 36, divided by 2, divided by 2, x equals 18. And there we go. So you can see how we can use these congruent relationships to find missing measurements.